Welcome back, students. This is the Q&A session 16 from the playlist of current electricity. The topic is the infinite network of resistances, and the question for this session is written here on this board. This figure was provided along with this question, and the question is: find the effective resistance of the infinite ladder network of resistances as given. So this is the infinite ladder network of resistances, and we have to find the effective resistance of this infinite network of resistances. So let us consider, let us assume that the effective resistance of this network is R. Now, since this is an infinite network of resistances, therefore the addition or the subtraction of any one loop from this circuit is not going to make any appreciable or substantial change in the effective resistance, that is R. Or in other words, we can say that the addition or the subtraction of any loop from this circuit will keep the effective resistance equal to R. So here this infinite network of resistances can also be redrawn as now this is 1 ohm, this is 2 ohm, and this is R. And see, what I have done is I have, since the effective resistance of this infinite network of resistances has been taken as capital R, so the effective, we can also say that the effective resistance of this part of the circuit, which I am showing here with the help of these dotted lines like this one, can also be taken as R, and this effective resistance will be in parallel to this 2 ohm resistor. So now this is the, you can say this is the equivalent circuit, and now we are in a position to find the value of R. So what we will do is I will be finding, so this 2 ohm resistor and this resistor R, they are in parallel. So the effective resistance of this 2 ohm resistor and this resistor R, this is going to be equal to, that is 1 upon, let us say their equivalent resistance is R dash. So R dash will be equal to 1 by 2 plus 1 by R, or simply we can say that R dash will be equal to 2R divided by R plus 2. Okay, now this equivalent resistance of this 2 ohm resistor and this resistor having a value of R will be in series with this 1 ohm resistor. So we can, let us say the effective resistance of 1 ohm resistor and R dash, this is going to be will be equal to 1 plus 2R divided by R plus 2. So this will be equal to R plus 2R, that is equal to 3R plus 2 divided by R plus 2. Now this is the effective resistance of this circuit, which has been redrawn after considering the fact that the effective resistance of this part of the circuit is equal to R. Now, what I will be doing is, this 3R plus 2 upon R plus 2 is the effective resistance of this infinite ladder network of resistances, and the resistance of this infinite network was taken as R. So this can be written equal to, this can be treated as equal to R. So by solving this equation, we will be able to find the value of the this effective resistance of this infinite network. So this will be equal to R square plus 2R, and this will be to plus 2R, this is equal to 3R plus 2, or it implies that R square minus R minus 2, this is equal to 0, and from here we can write this R square minus 2R plus R minus 2, this is equal to 0, or simply R minus 2 plus 1 R minus 2, this will be equal to 0. So from here, the value of R is equal to 2 and minus 1. Now since the value of the resistance cannot be taken as negative, therefore the effective resistance of this infinite network of resistances will be equal to 2 ohm. This is equal to 2 ohm. So the correct option here is B. So in this question, the most important thing which we have to remember is that in this this infinite network of resistances, the addition or the subtraction of any one of the loop will not going to make any substantial change in the effective resistance of the entire circuit. So what I have done is I have taken this part of the circuit and I have taken the resistance of this part of the circuit equal to R. So so after that, what I have done is I have redrawn this circuit as shown in this figure, and from here I have calculated the effective resistance of this circuit, and after that I have equated this effective resistance equal to R, and thereafter we were able to find the value of this effective resistance, which was equal to 2 ohms. So thank you very much for joining this session. In the next session, I will be coming up with a different topic from the same chapter, that is current electricity. So till then, have a nice day. Bye.